frozen state in polar caps, clouds, or permafrost below the planet's surface. So there's frozen water in the Mars environment, like in its clouds and the polar caps below the planet's surface, but it's too cold, so it's frozen water. There is evidence that liquid water existed more abundantly on Mars in the past. The most obvious form of evidence consists of features on the surface of Mars that have been cut by running water. This is the liquid water erosion that I've been mentioning. Some narrow, dry riverbeds are found on Mars, meandering across the surface of the planet like rivers on Earth. The dried up Martian riverbeds are approximately 3 billion years old. 3 billion, judging from the density of impact craters atop them. In addition to the narrow, relatively orderly riverbeds, there are also broad flash flood channels found on Mars, the result of catastrophic floods rushing across the surface. The outflow channels can be hundreds of kilometers wide and contain teardrop islands. There's even some teardrop islands. Ooh, we'll show you these teardrop islands. I have a picture of them right here. Thus, liquid water existed abundantly on Mars in the past, although it does not at present. This indicates that Mars may once have had a thicker atmosphere and a higher temperature in the past than it does now. So if it had a thicker atmosphere, it could have been warmer there, and that would have allowed the liquid water to exist. Mars has two small irregular satellites called Phobos and Deimos. Fear and panic. God of war and all that, you know. Phobos and Deimos are both heavily pitted with craters, just like our moon has craters too, because these are older surfaces. Moons are sometimes, well, our moon, I'm not saying every moon, but some moons can be pretty geologically dead. So you see those craters even later on, okay? As in even now. As in even much later after the cratering actually happened. So they are also undifferentiated. So these moons, Phobos and Deimos, are heavily pitted with craters, showing a history of collisions with other smaller bodies. I mean, just like our moon has craters too, so that's not surprising. And by the way, the moons of Jupiter that we have also talked about in the past, some of them are very geological. One of them is like the most geologically active site in the freaking entire solar system. And one of the sort of things we look for is if you have a lot of craters, it means that you're an older surface and you did not have enough volcanoes to cover up the craters. But if you have a ton of activity, like geological activity, like volcanoes and things happening, then you're a newer surface and you're not going to have as many craters, okay? These moons are also undifferentiated, indicating they have never been hot enough to melt. So undifferentiated, what differentiation means, chemical differentiation, where the heavier stuff will sink to the bottom or to the center of the object, and the because these things are mostly spherical, right? And then the lighter stuff will be on top. So like, for example, we have an iron core, which is iron is heavy, but we have sand on the surface, right? So different chemical differentiation is something that we also see quite a bit in the rocky planets, of course, in the terrestrial planets. And if you have undifferentiated objects like these moons, then what that means is that they might not have been big enough, hot enough, because sometimes for something to be very hot, it has to have enough mass for it to be really hot. Like, for example, the sun is really hot and it has a lot of mass. It has 99.9% of the mass of the solar system, or something crazy like that. It might be 98.9 or 99.9, whatever, but that's how much mass the sun has of the solar system as a fraction. So, and it's very, very hot. It has obviously a nuclear reactor in its belly, which is how we get all the heat, like sun energy, all of that, to be able to live on Earth. But basically, if you are not very big, you might not be very hot, which means that you might not have melted enough for your stuff that make you to be very chemically differentiated, where the lighter things are on top and the heavier things are in the bottom, okay? Which is the case with these moons, Phobos and Deimos of Mars.